Okay, so we are being recorded, fellas. All right, so let's get our little ECM overview pulled up. And so this morning we're going to be doing an ECM product overview. Now, as it turns out, the majority, as we're pulling that screen up, the majority of our ECM products are really in furnace products. So we're going to be talking about some furnace control boards. We're going to go literally over every terminal, every input, and every output on the boards. So that we're totally familiar with how to hook them up, how to wire them, and so on. In addition, we're going to have a little low voltage review in case you have like an outdoor unit, a two-stage outdoor unit, and maybe an AE air handler inside. And so these are just some of the highlights that we'll be talking about today as we take a look at our little ECM overview this morning. Fellas, as usual, if you have any questions or comments during the sessions, please unmute your mic and just ask those good questions or comments. There's only a few of us this morning, and so it's going to be a real open forum. But by all means, if you do have questions, ask those questions. Don't get away from this training session without having those questions answered, please. So in this ECM training module, we will be looking at some simplified low voltage drawings for a typical ECM applied product. In addition, we'll be reviewing control board setup for the TM9E or the TME boards, the TMY boards, and the TMV furnace boards. And we're going to ask that you please follow along and again ask those good questions if you've got questions throughout the training session this morning. Now, one of the highlights we're going to be talking about, we're going to talk about low voltage wiring if the indoor product has a Y1 and Y2 terminal. So let's give an example of that. Let's say you have a variable speed air handler, or you have a TM9E furnace, for instance, or a TM9Y furnace. You're going to have a Y1 and a Y2 terminal. So if you've got a Y1 and Y2 terminal, we'll talk about how to utilize those terminals, especially if you've got like a two-stage outdoor product. And some other examples would be like a variable speed air handler or a furnace with multiple stage cooling capacity, which you're going to see involves most of our furnaces, with the exception of the PSC, the older PSC style furnace. But even our single stage TM9E or a TM8E furnace actually has a Y1 and Y2 capability. So we're going to talk about how to wire the indoor product up, low voltage wiring review if you have a Y1 and Y2 terminal. In addition, we're also going to talk about how to wire a unit up if you don't have a Y terminal. So there are air handler products, specifically like the AE air handler. The AE air handler doesn't have Y terminals. It doesn't have a specific wire for Y1 or Y2. And so we're going to talk about how to wire that up, not only for single stage, but also it'll be utilized for a two-stage product. We'll show you how to wire that up for a two-stage product. And again, fellas, I want to stress in this ECM motor overview, we're going to be going over some control boards and stuff like that, but please be free to unmute those microphones and ask those good questions this morning as we do our training session for you this morning. So the first thing I'd like to talk about is oftentimes we see our two-stage cooling, two-stage heating products hooked up with an outdoor unit that has two-stage capability. And some examples would be like our AL or HL19 product would be a two-stage product. We also have a two-stage 17 SEER product, like our TH17 is also a two-stage product. It has a two-step scroll compressor out there. The other thing I'd like to stress is that even though it's a 5-stage, even though the TH16 is a 5-stage product, you wire it like a two-stage product. It's a conventional 24-volt unit. That little TH16, a 5-stage or 5-step heat pump, it's strictly 24-volt wiring. And the way you would wire that up, you'd actually wire it like a two-stage product outside. And then the outdoor unit makes some intelligent decisions on when to stage and how to stage from 50 to 100% capacity in 5 steps. So just kind of keep that in mind as well. Even though we're on our PowerPoint screen, we're showing a two-stage outdoor unit. This also would apply, the same basic wiring schematic or the same basic wiring scheme would also apply to the TH16 5-stage heat pump that wires like a two-stage unit. Can everybody see my screen okay? I've got currently I've got a little block diagram of PowerPoint slide up. It says two-stage outdoor low voltage wiring review with Y1 and Y2 terminals available. Can everybody see that okay on their screen?
Yes.
Everybody good? Okay. Well, as you take a look at this little block diagram, let's go ahead and just start out with the fact that from the thermostat to the indoor unit, with the indoor unit does have a Y1 and Y2 terminal. This could be a variable speed air handler. It could be a variable speed furnace. It could be a TM9Y. It could be a TM9E furnace. As long as they've got a Y1 and Y2 terminal, this wiring scheme would work. And so we're going to presume that probably the toughest outdoor unit that you'd have would be a heat pump, with the most terminals and stuff. So we're going to go ahead and feature a heat pump outside, because if you can wire a heat pump, you can certainly wire just a straight AC unit outside. So we've decided to do that with this, because this would be the most wiring that you'd ever see, would be if you had a heat pump outside. So before we get started on the block diagram, let's just talk through this a little bit. C is 24 volt common, and that's going to go all the way from the thermostat to the indoor unit to the outdoor unit. That'll just be a straight run all the way through. This is pretty common and straightforward on low voltage wiring. Your R terminal is your 24 volt hot, and it would go between R to R on the indoor unit to R outside, which is going to be your 24 volt hot, powering all those components up on the 24 volt system. Your G terminal from the thermostat will go directly to the indoor unit to the G terminal, and that will be your fan terminal. That's your fan terminal. Basically, when the thermostat calls for fan operation, it'll energize the G terminal, and the indoor unit will have that G signal for fan operation. Now, because we're looking at a heat pump, we're also going to have an O terminal. That O terminal from the thermostat will go all the way through again, from O on the thermostat to O on the indoor unit to O outside, all the way through, just a straight circuit. Now, if you have a Y1 terminal on the indoor unit, typical wiring is going to be Y1 from the thermostat. This would be your first stage heat pump operation on a two-stage unit. So Y1 from the thermostat to Y1 on the indoor unit to Y1 outside. So all those wires, those are you might say hard wires that are going to be wired in, and these are wires that are always going to just go straight through, so to speak. Now, where we start to deviate a little bit from other manufacturers is where we're going to let the outdoor unit make some intelligent decisions on when to stage the heating, the auxiliary heating. And so what we're going to do, we're going to take W. So Y1 from the thermostat goes all the way through, as I said. And we're going to select a motor tap. I forgot to say that. We're going to select a motor tap on the ECM to provide 60 to 65% airflow on a Y1 call. So we want to make sure and do that as well. Then we're going to take W from the thermostat, and we're going to take it straight outside. We're not even going to touch W1 or W2 on the indoor unit, because what we're going to do with our two-stage heat pumps like that, we have the capability of actually letting the outdoor unit stage the heating based on outdoor temperature. Now, if a contractor doesn't want to do that, what they can do, they can let the thermostat do their staging if they want to, and not even use that W circuit outside. But the most common way we see this being hooked up is you have W from the thermostat straight outside, and then we're going to allow the outdoor unit to stage first and second stage auxiliary heat. In addition, our Y2 from the thermostat goes straight outside, because on our two-stage outdoor unit, again, we're going to have a Y2 output from the outdoor unit to bring on second stage. And again, this could be a result of it could be the result of outdoor temperature. It could be the result of staging. It could be the result of intelligence on the outdoor unit, like on the TH16, for instance. The outdoor unit is going to determine when you're going to have second stage airflow. So Y2 from the thermostat directly to the outdoor unit is also a normal scheme if you've got the outdoor unit staging second stage airflow. Then from the outdoor unit, we're going to have Y1 out, and that'll come into the indoor unit, and that'll be first stage auxiliary heat. Now remember that auxiliary heat could be a dual fuel system where the indoor unit's a furnace, or it could be a variable speed air handler in our example that has a Y1 and a Y2 terminal. So W1 out from the outdoor unit comes in and hooks up to W1 on the indoor unit. W2 output on the outdoor unit comes in and hooks up to W2 on the indoor unit. And then Y2 out from the outdoor unit comes in and hooks up to Y2 on the indoor unit. So in this scheme or scenario, what we're doing, we're allowing the two-stage outdoor unit to actually stage or call. When you get a second stage call on the outdoor unit, it's going to allow that outdoor unit to bring on second stage airflow inside. So this is a very, very common wiring scheme, again, with an ECM product. If you've got the indoor unit that has the capability of a Y1 and a Y2 terminal. Now, real quick, guys, as a quick explanation, anytime we're talking about ECM, we're talking about high efficiency indoor blower motors. That ECM, if you didn't know this, maybe jot this down or kind of keep in the back of your brain. ECM means electronically commutated motor. And that's a big fancy word for a high efficiency motor. And what that high efficiency motor technically is, it's a three-phase type of motor that has a variable frequency drive on the back of that module. And that module actually drives that three-phase motor. And so that's pretty interesting. It's a very, very high efficiency motor, and it has the ability to deliver airflow unlike any other type of motor technology that we have in the inventory. So it's a very, very powerful motor, and it's again, a very high efficiency motor. Is there any questions or comments so far on what we've talked about so far? Okay. Well, the next little block diagram we're going to look at, we're going to talk about how we may hook up a two-stage outdoor unit if we do not have a Y terminal on the indoor unit. So an example would be like an AE air handler. So if you've got some air handler products out there, if you're utilizing the AE air handler, you're going to notice that the air handler doesn't have a Y terminal, doesn't have a yellow wire. So how in the world would we hook that up to where we're going to get normal operation? And again, we'll just use a two-stage outdoor heat pump as an example. So in our previous examples, we saw that what we did, we took C and we took it all the way through, C to C to C. R terminal goes R, 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 just like we did before. Same way with O terminal. The O terminal goes all the way through from the thermostat straight to the outdoor unit, because there is no O terminal on the AE air handler, so that just goes straight through. But then let's talk about that G. So the G terminal from the thermostat goes to G on the indoor AE air handler as our example. It has no Y terminals at all. So the G terminal goes to G on the indoor unit. Now here's how this happens. So what's going to happen is that the contractor, when he sets this up, if he has an AE air handler, he's going to set up his G airflow. In other words, when you get a G call from the thermostat for the indoor fan to come on, that fan speed has to be 60 to 65% airflow. So when I get a fan call, it's going to drive that fan to 60 to 65% airflow. And by the way, this is also the Y1 airflow demand. And here's how this works, because remember, when the thermostat calls for Y1 operation, or it calls for first stage compressor operation, it automatically, electrically, generates a G call as well. So the thermostat really becomes the main fan control in this example, because anytime you get a Y1 call, you're also going to generate a G call. And so if we set our G airflow up on the indoor unit, if we set up our G airflow at 60 to 65% airflow for that first stage of cooling, we're going to automatically have 60 to 65% airflow on a Y1 call. Does that make sense to everybody? Okay, so that's, because we've had some questions. I've had some call-in questions, from contractors. Well, gee whiz, how do I get my Y1 airflow? Well, it's really the thermostat that's generating the G call and the Y1 when you have that first stage Y1 call on the thermostat. So then what we'll do is we'll take Y1 directly outside to the outdoor unit, because remember, whenever we have a Y1 call, we're going to bring on first stage on the outdoor unit, and we'll also generate a G call from the thermostat, and that'll be 65% airflow for that first stage compressor. We'll then take directly W for the thermostat directly outside, because again, we're going to allow the outdoor unit to stage first and second stage auxiliary heat on the indoor unit. and then we'll also take Y2 or second stage compressor operation directly outside. So those three terminals, they don't even touch the air handler. Y1, W, and Y2, they don't even go to the air handler. They go directly outside. Is there any questions or comments so far? Okay, so from the outdoor unit, we'll then take a W1 output and bring it to the indoor unit for our first stage auxiliary heat. W2 out from the outdoor unit comes in and hits W2 on the indoor unit, our second stage heat, a wire or pigtail. Now watch this, team. Y2 out from the outdoor unit comes in and goes directly to the ECM motor. Now this is a field fabricated wire. So if I take Y2 out from the outdoor unit, this is a field fabricated wire that the contractor will manufacture when he installs this, if he installs this on a two-stage unit outside. So he'll take Y2 out and bring it straight in. It's a 24-volt signal, and then he will field fabricate just a spade terminal on the end of that thermostat wire that he brings in from Y2 out, and he'll land it directly onto the ECM motor, the desired speed tap or motor tap to provide 100% airflow. And so, team, this is really important also. We remember that on an ECM type of motor, if that ECM motor has multiple speed commands, they're going to be 24-volt commands. If it has multiple speed commands, the ECM motor always drives to the highest speed command that it's receiving. So if it's getting a Y1 call, for instance, if it's getting a Y1 call or a G call at 65% airflow, and in our example, if it sees another speed tap command from our Y2 out for second stage airflow, even though it already has a Y1G command at 65% airflow, if it sees an additional command for a higher airflow setting, it'll drive to the highest airflow setting. So this is an important concept with all ECM motors. If they receive more than one speed command, they always take the priority, or they always take the highest speed command as priority. Is there any questions or comments on that in this basic low voltage block wiring? If we have, for instance, an outdoor unit, a two-stage outdoor unit with an AE air handler with no Y terminals at all, or if we have an indoor unit with Y terminals. Any questions or comments on this? Okay, well, at this time then, let's go ahead and review some very, very common products that we're seeing at our wind supply locations around the country that sells furnaces. We're going to be talking about the TME single stage. This is an ECM board. That E on the model number, TM9E, TM8E, that means it's a high efficiency, standard high efficiency motor. And so remember, team, always the ECM motors have power to them all the time. Anytime you power the product up, or the furnace up, or the air handler up, anytime you power up an ECM product, it's going to have power to the motor all the time. And then what's going to happen, we're going to provide it with 24-volt commands to tell it what to do. Now those 24-volt commands, they could be a jumper setting, for instance, on a variable speed control board, or they could be hard physical motor settings that we're going to see, for instance, on this board. We have a low cool and a high cool in the upper right-hand corner of your picture there. And so those are actual motor speed taps. They're 24-volt commands from the board to the selected low cool speed on the motor, or the selected high cool speed on the motor, and so on. So this is an important thing about the ECM motor we need to remember as well, that it has power to it all the time. Anytime you have power to the furnace, that ECM motor is powered up. And then we send 24-volt commands to it to tell it what to do. Is there any questions on that? Okay, well, let's go ahead and review our high efficiency motor, ECM motor, on a TME single stage heat, two-stage cool control board. And again, this would be a control board that you would find in an ECM product that had the TM9E or the TM8E furnace control board. And let's go over all the inputs and outputs. We'll talk about this board, and then we'll certainly entertain any questions you have. And please, by the way, if you do have a question midpoint or through this next slide, just unmute your mic and go ahead and ask that good question, and we'll be glad to answer that question for you as we look at the control for every input and every output on this control. So this is a single stage heat, two-stage cool, capable control board featuring a high efficiency ECM motor product. So starting out at the left-hand side, on the lower left-hand corner, you're going to see that we're going to have some low voltage terminals. So let's go ahead and start out with Y1. Y1 is your first stage cooling call. So in this example, as we talked about in our previous little block diagram, if the indoor unit has Y1 and Y2 terminals, so this would be a great example of that type of board. So Y1 is your first stage cooling call. Y2 is your second stage cooling call. Now again, these are your thermostat connections going up to your thermostat. W is your heating call. Now remember, team, this is a single stage heat, so we're just going to have a single W wire coming in and landing on W terminal. R is 24 volt hot. G is your fan call. And C is your 24 volt common. That's pretty standard in the industry. R, G, and C, and so on. Those are all pretty standard terminals in the industry. Now, right above the low voltage terminal strip, we're going to have a fan speed. And now it says fan speed. Now what this is a continuous fan speed selection. So if the homeowner or the building owner goes over to the thermostat assembly and they switch the fan from auto to on, this jumper right here allows the technician to field select what speed the motor is going to run on a continuous fan call. So in other words, if I generate a G call on the control board, and that's what you're doing when you go from auto to on the thermostat, you're actually generating a G only call on the control board. And so if the board sees a G call on the control board but no other demand from the thermostat, it'll drive the fan to the speed that's selected on that jumper right there. So so the selections are G, high cool, heat, and low cool. And so those are, if you look on the right-hand side of the board, the upper part of the right-hand side of the board, you'll see that there's different speed taps going to the motor. So based on where that jumper selection is, if the homeowner calls for continuous fan, and others, they just want the fan to run all the time, the speed with which it'll run will be based on that jumper where it says fan speed. Any questions or comments on that? So again, this is a continuous fan speed selection. Right above it is our heating off delay blower selection. And so once the furnace is concluded with a heating call, what will happen, the fan continues to run after the thermostat is satisfied on the furnace. The fan continues to run for a certain amount of time after the call for heat goes away. Well, this jumper here determines how long that fan's going to run once the thermostat is satisfied. And the selection is 60, 90, 120, or 180 seconds after the call for heat goes away. Now, typically, you might want to write this down or make a note. Typically, we set those at about 90 to 120 seconds from the factory. Right above that is the last error button. That last error button allows the technician to pull flash codes off the board, and he can depress that button and he can pull flash codes off the board, and it remembers the last 5 faults. Now it should be noted, if the technician should hold that button down for about 10 to 15 seconds, it'll clear the memory. And so the technician has the capability of pulling previous flash codes or faults off the board, but it only remembers the last 5 faults, and then it'll go ahead and roll off the end, so to speak. So if it has like 7 faults, it only remembers the last, the most recent 5 faults, and then it just remembers the most recent 5. And then if he wants to clear it, he holds the button down for about 10 or 15 seconds, and then it will clear that fault. Okay, right as we move around the board, we have a status LED to retrieve diagnostic flash codes. And it should be noted that diagnostic LED will flash either green, red, or yellow based on the flash code. Now as we kind of move around the top of the board, you'll notice that there's some 24 volt motor terminals. you'll see one that says park. And what that park means is that's for unused motor tap. So if you have like a 5-speed motor, but you're only using 2 or 3 of those speeds, you'll have a place to put that extra terminal. So that's a park terminal, what they call a park terminal. Then you have a G terminal. Maybe back up for a second. You have a G terminal that would be selected speed tap for a G only call. And then you also have a 24-volt common where it says that little area I have highlighted, 24-volt motor. Now as we move down the right side of the board, we have different speed tap selections: low cool speed, high cool speed, and heating speed. Now it should be noted that we always ship these on the highest possible speed that we can from the factory. However, once the install technician hooks the furnace up, he's going to want to make sure and he selects the proper speed tap to provide 400 CFM per ton of cooling capacity of the outdoor unit. And so when he sets the speed taps up for his cooling speed, his high cool speed, if he's on a 2-stage unit, needs to be for 400 CFM per ton. And so to give an example, let's say we have a 2-ton unit outside, he'd want to set that high cool speed up for 800 CFM. And then his low cool would be 65% of that. And then the heating speed will be based on the size of the furnace and so on. And so the ability to change those speed taps and select high cool, low cool, and heating speed is an important setup procedure for our technicians. Any questions or comments on that? Okay, team, if we move down the board, we see we have an EAC terminal. That EAC terminal is a 120-volt AC output for an electronic air cleaner. That EAC is an electronic air cleaner terminal. That L1 is where we power up the line voltage components on this board. This is where the 120-volt AC comes into the board to power up components like the hot surface igniter and so on, and the transformer and so on. So this is the L1 or high voltage input to the board. Right below that terminal is we have what we call an XFMR terminal. That XFMR terminal is for a transformer. That's the transformer line voltage, 120-volt line voltage for the transformer. Now right below that, there's another terminal called line, L-I-N-E. That line terminal, what that is, that goes to the ECM motor, because remember we had mentioned that anytime you power up an ECM product, the furnace or that product is powered up all the time. It has line voltage to it all the time, but the motor's just sitting there doing nothing. And so even though it's powered up all the time, we're going to drive that motor to whatever speed we want with a 24-volt input. And so all ECM motors work with the same principle. They have power to them all the time, and then we're going to provide a 24-volt signal to tell that motor what to do. And so this is the terminal that powers up that ECM motor on this particular product. All the time you'll have 120 volt on that ECM motor via that line terminal. All right, below that line terminal we have a 120 volt humidifier output. And on this control board, what we do, we give you the capability of controlling the humidifier, energizing the humidifier from this 120 volt AC humidifier terminal. Now it should be noted this is a dry isolated relay output, and it gives us the capability of running a humidifier off of our control board without actually having to have a bunch of extra relays or extra controls. So that's pretty nice. And so this humidifier terminal will be energized anytime we have a W or a heating call. Right below the humidifier terminal we have neutral terminals. These are 120 volt neutral terminals for all of your line voltage components like your transformer and your ECM motor and so on that has your line voltage power. Your neutrals will hook up to this particular area, and by the way, all those neutrals are tied together internally, so it doesn't matter where the neutral wires go. As long as it's on a neutral terminal, they're all hooked up together. As we move around to the bottom of the board, we have an output harness to the hot surface igniter and the inducer fan motor. And so this is where this is harnessed in for those components. Now please notice something, team. If you take a look at this control board, you'll notice there's no harnessing or any wires hooked up to this board And the reason we did that is for training purposes. We've taken all the harnesses off so we can talk about all the components on the board. Now, naturally, when this board is installed in the furnace, all this stuff's going to be harnessed in. Your neutrals will be plugged in, and your transformer will be hooked up, and all these harnesses will be plugged in. And so the technician doesn't have to do that during install. It's just that we've removed all those harnesses in the photos for training purposes. So don't worry about, oh gee, what do I have to hook up if a technician has this board. Now if he has to replace the board, naturally he'll have to take all the harnesses off and replace all the terminals and so on. So anyway, this is the output harness to the hot surface igniter and the induced fan motor. Right next to that is a flame current pad. Now this is a really neat Champion product, furnace product exclusive. I don't know of any other manufacturer that does this. Anyway, what this is a flame current pad that allows the technician to check flame current right on the board with a voltmeter. So instead of having to have a special flame current meter, or instead of having a special meter that has that flame current capability for measuring flame current, this is very, very simple. All the technician has to do is if you take a look at those two little solder spots, or those two little test points, it says negative and positive. What that is, it's basically a 1 volt DC on his voltmeter is equal to 1 microamp flame current. And so that's pretty cool. So now the technician, all he has to do is just take his normal standard voltmeter that he has in his truck anyway, in his tool bag anyway, and go to DC volts, and then he reads voltage on that, which is actually translated into flame current on the control board circuitry itself. So now, again, he doesn't have to have a special meter for that. All he has to do is take his voltmeter, go to DC volt, and remember, 1 volt DC is equal to 1 microamp flame current. So it's a real easy place for him to check flame current now without having to have a special meter. Is there any questions or comments on that? Again, a very, very nice feature that all of our Champion furnaces have on them. If we move around the board, we see we have a 3 amp fuse for onboard protection. Most of our products, they will allow up to 5 amp fuse. But what I always ask the technicians to do is just to make sure and look at the control board, because they will typically have a silk screen, or they'll have a little text next to that fuse that says 5 amp maximum. And so, but we ship them typically with a 3 amp fuse for onboard protection. Right next to the fuse, you're going to find a 12-pin harness on this board. And that 12-pin harness is where all of our 24-volt inputs and outputs will be found for our gas valve, for instance. The gas valve will hook into this harnessing. The pressure switches, the safety circuits, the rollout switches, and so on will all hook into that 12-pin harness. Okay, so that concludes the rundown, if you will, or the layout of our TME type of control board found on our single stage TME 9, TME 8 furnaces, which are single stage heat, high efficiency motor, and two-stage cool. Any questions or comments on the layout of this board before we take a look at a couple more boards and then open the floor up for any final questions or comments? Is everybody good? Okay, team, well, let's go ahead and continue with our overview then. The next board we're going to look at is a TM9Y. And again, this is a very popular furnace. We're seeing a lot of movement in our wind supply locations around the markets that have furnace markets. And what this is a two-stage heating, two-stage cooling control board that has specifically the high efficiency motor in it, but it also it's a standard high efficiency motor. It's not variable speed. We'll talk about variable speed towards the end of our training program this morning. But the standard ECM control board, so you're still going to have some 24-volt wires or motor taps that the technician's going to have to deal with, high heat, low heat, and so on. He'll have to select those accordingly. So this board has a Y1 and a Y2 terminal on it, as well as a W1 and W2 terminal, because it's two-stage heat, two-stage cool control board featuring a high-efficiency ECM motor with a two-stage heat, two-stage cool configuration. And again, a TM9E, or excuse me, a TM9Y or a TM8Y would be the furnace products that you'd find this control board in. So as you take a look at the control board, we'll start out on the left-hand side again. Y1 is our first stage cooling call. Y2 is our second stage cooling call. W/W1 is our first stage heating call. Now class or team, one of the things we want to remember is that the reason we have that designated W/W1 is we know that sometimes you may be stuck with a single stage thermostat. For instance, the contractor may have a situation where he doesn't have enough wires behind the wall. Or maybe he doesn't, the homeowner doesn't want to change the thermostat out, and so maybe he's taking out a single stage furnace product, and for whatever reason, he doesn't have the wires, he doesn't have the capability, for whatever reason, he's stuck with a single stage thermostat. If you're stuck with a single stage thermostat, be sure that you land the W, the heating call, on this terminal. That's why we designated W/W1. If you have a two-stage thermostat, it's your first stage heating call, W1. But if you only have a single-stage thermostat, you land it on this W/W1 terminal. And then if you have a two-stage thermostat, two-stage heating thermostat, your W2 will then go to your W2 terminal for your second stage heating call. Any questions or comments on that before we continue? Okay. So remember, if you have a single stage thermostat, be sure and land your W terminal on a single stage thermostat on the W/W1. R is 24 volt hot, just like we had before. G is your fan call, just like we had before. And finally, C is 24 volt common. And again, just very, very straightforward on the low voltage terminals. As we move around the board, we see that we've got our last error button. It functions just like the one we had before. If you depress it, you can recall the last 5 errors. It remembers the last 5 errors. If you hold it down for 10 or 15 seconds, it'll clear the memory. Right next to the last error button, you'll find that it has a status LED. It's going to be the same thing. It'll flash either red, green, or yellow based on the flash code. As we move around the board, you're going to have what we call continuous fan on speed selection. Now, what these are, instead of physical jumpers like we had on our previous board, on our TME board, the TMY board that we're looking at now actually has dip switches. And so those little dip switches, you can move those to give you a continuous fan on speed selection. So remember, team, whenever the board sees a G only call, so let's say the homeowner goes to the thermostat assembly and they flip the switch on the fan switch from auto to on, those dip switches there will determine how fast the fan's going to run on continuous fan speed. And so electrically, it's just a G only call from the thermostat. And based on the dip switch selection, you'll have either a low heat or high heat, low cool or high cool speed selection for your continuous fan. Is there any questions or comments on that? Okay. The next little bank of dip switches is our heating off delay. We've talked about that before. You're going to set those dip switches up according to how long you want the fan to run after the call for heat goes away. So that's our heating off delay blower selection. And again, if you take a look at the graphics and so on closely, you'll see it's 60, 90, 120, or 180 will be the amount of time that fan will run after the call for heat goes away before it shuts off. Now the next thing we're going to talk about is staging. Now this is something unique to the TM9Y and the TM9V, or the variable speed and the two-stage control board we're talking about. If you're stuck with a single-stage thermostat, now we mentioned earlier that if you're stuck with a single-stage thermostat, you're going to land your low-voltage wires from your thermostat on the W/W1 terminal. Well, if you're stuck with a single-stage thermostat, you can actually get some staging function with these dip switches. So instead of just having it running on single stage all the time, this staging function will allow a single stage thermostat operation on this high efficiency ECM motor control board. And so the selections are off, 10 minutes, auto, and 20 minutes. And so if those dip switches are both in the up position, as we take a look at our little graphic or the picture of our control board here, we see that we have no staging function at all. So if you have those in the off position, with a single stage thermostat, you will never come out of first stage heating. If you have it on the 10 position, it'll run for 10 minutes in first stage. Now remember, you're stuck with a single stage thermostat, so all it's going to get is a W/W1 call from the thermostat. So if you're stuck with a single stage thermostat and those dip switches are in the 10-minute position, what will happen is the furnace will run for 10 minutes, and if the thermostat is still calling for heat after 10 minutes, it'll automatically go to second stage heating to satisfy the thermostat. Likewise, if it's in the 20-minute position, if you have a call for thermostat operation, it'll run 20 minutes on first stage on a W/W1 call. And then if you still have a call after 20 minutes, a heating call, it'll then go ahead and bring on second stage heating to finish that call. The last option is what we call auto. If you take a look at that dip switch on the left-hand side, if it's down and the dip switch on the right is up, that's the auto position. In the auto position, now remember team, if you're stuck with a single stage thermostat, this auto function, what it does, it plugs in some intelligence on the board. And the board actually starts making intelligent decisions on when to stage second stage heat. And so we recommend, if you're stuck with a single stage thermostat, to make sure those dip switches are in the auto position, because then what will happen is the board will make intelligent decisions on when to stage for second stage for optimal operation. And so what it does, it's actually looking at the thermostat activity. It's looking at how long it takes to satisfy the W terminal as far as time is concerned, and then it starts making decisions on when it would be a good time to stage for second stage. So you can still get staging capability with this board. To my knowledge, I don't know of any other manufacturer that does this. So this is kind of something unique to the Johnson Controls Champion product. As far as I know, no other manufacturer does this. And but it allows us to stage and have intelligent staging on our control board if we're stuck with a single stage thermostat. Now team, we always recommend that if you have a two-stage product, be sure and have a two-stage thermostat on there. But if you're stuck with a single-stage thermostat, we can still give you some really nice staging function with these staging dip switches, either auto, 10-minute or 20-minute staging, but we recommend put it in the auto position. That way the board makes some intelligent decisions on staging. Is there any questions or comments on anything we've talked about so far? Okay, well good. Let's go ahead and continue our overview of our control boards. And again, please, team, go ahead and open up your mic. If you do have questions, be glad to be interrupted. It will not be an issue at all. We've blocked out some time for you this morning, so don't feel compelled to not ask questions if you've got questions. As we move around the board, we have blower speed tap selections. You'll notice there's a low heat and a high heat, low cool and high cool. And so those speed taps will go down to our ECM motor, and the technician, when he sets the furnace up, he'll have to make sure and select the proper speed tap based on based on the amount of airflow necessary for high heat, low heat, high cool, and so on for optimal operation. As you move down the board, you'll see that there's a 120 volt EAC terminal before. Just like before, it's 120 volt anytime the fan is running. We provide a 120 volt on that terminal. And you'll notice a little red ball on there. That's just a little reminder that it is high voltage. So you'll remove that little red ball and you'll hook that up if you have an electronic air cleaner and you want to utilize that function to energize an electronic air cleaner anytime the fan runs. Right below him is a terminal called CIRC, C-I-R-C. That CIRC terminal is actually just like the line terminal before on our previous board. That's the terminal that powers up the ECM motor all the time. So anytime you have power to the furnace, that terminal will be energized to power up the ECM motor all the time. As you take a look down below, you have L1, and that L1 is the power from the power source to the control board to power up those line voltage components. XFMR is 120 volt output to the transformer. Power our transformer up. The HUME terminal is 120 volt output for a humidifier. If it's so equipped, you can utilize that 120 volt HUME terminal, to power up a humidifier. Down below that's our 120 volt neutral terminals, and again, all those neutral terminals are on a common bus, so to speak, so they're all tied together internally on the board. As we move around the bottom of the board, we see we have an output harness to our hot surface igniter and our inducer fan motor. Should be noted those are line voltage components. As we come around the board, we have our 12-pin harness with our 24 volt inputs and outputs to our gas valve and our safety circuits and our pressure switch and so forth. We have a 3 amp fuse on board, and if you look closely on the left-hand side of that fuse, you'll notice that 5 amp maximum. And so we ship it with a 3 amp fuse, but the technician, if they need to, can go to a little larger fuse if they need to. Now please notice, team, right in the middle of this board on the right-hand side, more towards the middle of the board, is our flame current pad on this particular board. That flame current pad, you'll notice that it'll have 1 volt DC will equal 1 microamp DC flame current for testing purposes. Okay, any questions or comments on the TMY control board that we have with a high efficiency ECM motor? Any questions or comments on the layout of this board? All right, team, well, the final board we're going to have a quick review over is going to be our TM9V or TM8V two-stage heat, two-stage cool, variable speed control board. Now, just real quick, just everybody unmute their mic real quick. Who has had the opportunity to sell some variable speed furnaces?
We do.
Okay, well, this will probably be a nice little review for you then. Again, this board is going to be found in our variable speed, two-stage variable speed gas furnaces. They're a great furnace, been very reliable. This board is also communicating capable, so if you have a situation where you have a fully communicating system, this happens to be a control board that you can go either 24 volt or communicating. And because it is a variable speed ECM motor, instead of having physical jumpers or instead of having physical speed taps that we're going to have to take down to the motor like our previous boards, this one we're going to have some airflow adjustment jumpers on the board itself. So the big thing about the variable speed is that you'll set up your airflow via jumpers on the board compared to actual speed taps on the motor. The other thing about this variable speed two-stage board is it's not only communicating capable with our 4-wire communicating system, but it also has the capability of actually utilizing a dual fuel setup with a heat pump very quickly and easily. You'll notice on this board when we get into our low voltage wiring, you'll notice that it actually has an O terminal built in on the board if you want to hook it up to a heat pump on a dual fuel application. So this is a great product. As a matter of fact, if I had natural gas in my home, which I don't down here in Mobile, Alabama, but if I had natural gas, I would have a TM9V in my home. I like this product that much. It's a great product. So as we take a look at our left-hand side of the board, let's talk a little bit about our low voltage wiring, and then we'll talk about how to set the board up, and then we'll answer any final questions or comments you might have on the ECM motor products. But at this time, let's go ahead and cover our low voltage wiring as we have a tour of the board, if you will, as we take a look at all the components and the layout of this board as well. So starting out on the left-hand side, we see we have a 24 volt common on our low voltage terminal. And so this board, again, is very, very versatile. This furnace is very versatile. You can hook it up to a standard 24 volt system, or you can go with our 4-wire communicating system. G is our 24 volt input from the furnace, or excuse me, from the thermostat. For G, our fan call. R is 24 volt hot. W1 is going to be our first stage heating coil. You'll notice it's also silk screen W/W1, because if you're stuck with a single stage thermostat, even on this great two-stage heat, two-stage cool, variable speed control board, if you're stuck with a single stage heating thermostat, we can still give you some staging function with a staging jumper, which we'll talk about in a little bit. Y2 is our second stage heating call, our second stage cooling call. Y1 is our first stage cooling call. And W2, just like before, is our second stage heating call, just like we had before. Now again, team, we always recommend that you have a two-stage thermostat on a two-stage product, but if you're stuck with a single stage heating situation, we can still give you some staging, which we'll talk about in a little bit. Now this board has a unique feature. It's called dehume. That dehume is actually a cooling dehumidification function. A cooling dehumidification function. And you'll notice a little bit later on when we start talking about some different jumper functions down in the lower part of the board. There's a jumper down there that says humestat. Now if that humestat is in the yes position, it starts looking at that dehumidification terminal. Now watch this. If you're in a humid environment, you can actually take a humidistat and put it between that dehume terminal, wire it electrically between the dehume terminal and the R terminal. And what will happen if you have a humidistat hooked up between dehume and R terminals, and that humidistat is in the yes position, that jumper is in the yes position, what will happen when it's humid in the space and the humidistat is open electrically, it'll actually activate this board to go to 85% airflow, cooling airflow. And what that does, that slower airflow starts pulling extra moisture out of the air during a cooling call for operation. Then when the humidistat closes electrically on a drop of humidity, once the space starts drying out a little bit, in a humid environment, what will happen is those contacts will close electrically on a drop of humidity and then allow the fan to come up to 100% cooling airflow. So that's a really neat little function if you've got a situation like I do down here in Alabama where it's real humid all the time. This is a great product to allow you to pull extra humidity out of the air during the cooling mode of operation, that dehume function. Now this is really, really important. If your contractors call in and say, hey, I don't have anything hooked up to that dehume terminal, what do I do with that humidistat jumper? You want to make sure it's in the no position if you're not going to utilize that circuitry. So make sure the humidistat is in the no position if you do not want to use that dehume function. Any questions or comments on that? Okay. Again, and just to kind of electrically show you, if you do have a humidistat wired between the dehume terminal and the R terminal, what will happen, it'll close on a drop of humidity when the space dries out and allows the fan to come to full speed in cooling. If that humidistat is, is open electrically, and that humidistat's in the yes position, and you have a dehumidistat, or you have a humidistat electrically wired in, like we show right here on the screen right now in this little graphic, what will happen if that is open electrically, and that humidistat's in the yes position in the cooling mode of operation, the fan will only go to 85% airflow to help pull extra moisture out of the air. So that's a very, very, very neat function. Right below that, we have our O terminal for cooling mode of operation on a heat pump. This will go to the, if you have this hooked up in a dual fuel application, the O terminal will be energizing the reversing valve on the heat pump in the cooling mode. As you move up towards the top of the board, you'll notice in the upper left-hand corner there's our 5 amp fuse maximum fuse terminals. I don't know why I don't have a fuse in the picture, but that's where your fuse would go, your low voltage fuse for low voltage protection, up to 5 amp maximum. As we move around the board, you do have 4 communicating terminals because this board is communicating capable. You can hook it up either 24 volt or communicating 4-wire communicating. Right next to that terminal, you have a status LED. That's your fault code. And that tricolor LED, one more time, team, will flash either yellow, red, or green based on the fault code you're looking at. Right next to the LED, you'll have a last error button that the technician can actually pull those errors off the board, the last 5 off the board, and then reset it if he wants to. Now, right below and to the right of that slightly is a CFM light. Now, this is a very unique feature on our high-efficiency variable speed ECM motor product. The CFM light will flash 1 time for every 100 CFM that the fan is blowing. So it's a quick visual check if you want to find out how much airflow you're actually pushing. You can look at that real quickly and it'll tell you the CFM that it's moving. Now, by the way, the CFM light is a common feature on any of our variable speed products. So if you have a variable speed furnace or a variable speed air handler, you'll have a CFM light that will report the CFM that you're actually moving through that cabinet. By looking at that CFM light, it will flash 1 time for every 100 CFM that ECM motor is pushing. Any questions on that? Any questions or comments? Okay, as we move around the board then, you've got some auxiliary, some optional temperature, auxiliary, and float switch terminals if you have a communicating system. This is for communicating system only. If you've got a communicating system, you can hook up some auxiliary terminals to report to the thermostat different functions as far as auxiliary switch, float switch, and temperature, and so on those auxiliary terminals. Right next to that is our ECM motor plug. Now remember, this is a variable speed ECM motor product. And so instead of having speed taps that you're going to select on the motor, you're going to actually be selecting speeds based on your jumper selection that we'll talk about in a little bit. And then this board generates 24-volt signals going down to the motor to tell the motor what to do. And so it's just a harness that goes right down to the ECM motor. From the board, it's a 6-pin motor plug, and that's where it hooks in for our 24-volt commands. Right next to that plug, we have our neutral pin. We have a 6-pin neutral pin that's harnessed in, again, from the factory, and then a couple extra neutral spade terminals in case you have accessory items like an electronic air cleaner or a humidifier you want to hook up to those auxiliary terminals. As you move down the side of the board, you've got a 5-pin plug. This is 120-volt output for your transformer primary, your hot surface igniter, and your inducer high and low speed for your 2-speed inducer. Right below that, you have a humidifier terminal for 120-volt output to a humidifier on a heating coil. And right next to that, you have a EAC terminal for the electronic air cleaner if it's so equipped. Now remember, team, anytime I have a G call or a fan call generated on this board, it's going to output 120 volt for an electronic air cleaner if so desired. At the bottom of this board, in the lower right-hand corner, you're going to notice that your flame current pad is down below on this board. And again, that flame current will be 1 microamp is equal to 1 volt DC. And the technician will just have to use his normal voltmeter to find flame current on this board as well. As we move around the board, there's your 12-pin harness with our 24-volt inputs and outputs based on our, based on the 24-volt requirements for the gas valve and the pressure switches, and all of our safety circuits will be harnessed in on that 12-pin plug. Now, because this is a variable speed motor, it's a variable speed ECM motor, we're going to set up airflow with jumpers instead of hard physical terminals like we have on our previous boards. So all of your airflow jumpers and your configuration for the board is going to be found about in the middle of the board, at the bottom of the board. And so let's start looking at those jumpers right now. So you have one set of jumpers called delay. The delay jumper is to adjust your cooling. This is a cooling on delay, so maybe make a note of that. This is a cooling on delay. And the jumper selection is A, B, C, and D. Now that has to do with geography. And what I mean by that is this. A is what we call normal. That would be someplace like maybe South Dakota, or someplace that's kind of dry in the wintertime and cold and all that stuff, but you don't have to worry about in the cooling mode of having a lot of humidity. So A is normal. B is humid, and that would be for humid environments like Mobile, Alabama, the Mississippi Gulf Coast, and so on. And that B is for humid profile. C is for dry. For instance, out in the Arizona or southern Colorado, it's a dry area out there, New Mexico and Arizona and so on. And D is temperate, maybe Memphis, Tennessee, or in the middle of the country. You get the idea. So these different airflow profiles, these delay profiles, what it does, it ramps the fan in the cooling mode of operation to pull out extra moisture if you have it on the humid profile. To give an example, if you have it on the B humid profile, I just happen to remember this one because I live in Mobile, Alabama, where it's so humid all the time in the summertime. But on the humid profile, on a cooling call, the fan starts out at 50% airflow for 1.5 minutes, and it ramps up to 85% airflow for another 6 minutes, and then it'll finally ramp on up to 100% airflow if the call for cooling is still there. So that ramping profile on that fan really starts pulling extra moisture out of the air on that initial call for cooling. And so the delay profile, just please make a note of this, this is a cooling on delay profile, and based on your geography, you can ramp that fan accordingly based on your geography. And so all that information is going to be found in the install information. And so everything we're talking about, is going to be found in the installation information for this furnace. And if you don't have the install guide that comes with the furnace, we always ship an installation manual with the furnace. But if you don't have that, you can always go to Navigator and then go to your offering catalog. And then you can dig in and you can find those documents and those printed documents in a PDF file for installation information, technical information. All that's available online through Navigator. So if you lose that, or if the contractor loses the install guide, you can always pull that for him in Navigator and get that information for him. So that delay profile is well explained in the installation information. We just wanted to review it quick for you as we move on with our review today. So is there any questions or comments on that cooling on delay jumper? Okay, the next two jumpers actually work together. The adjust jumper, and the cool jumpers, they work together to adjust cooling airflow for Y1 and Y2 input. So on my control board, if I have a Y1 and a Y2 input from the thermostat, what's going to happen is the control board is going to look at the position of those jumpers. It's going to look at the position of those jumpers, cool and adjust to determine how much airflow it's going to push for first stage cooling, second stage cooling, Y1 and Y2. Now remember, team, the cool and adjust work together. And so, for instance, let's say you might have a furnace, and I'm just making this up. You might say for 1200 CFM, you might have to have cool on the B position and adjust on the C position or whatever. And so the cool and adjust, they work together, and you'll find that information again in the install guide that comes with the equipment. The install guide that comes with the equipment will explain thoroughly. There will be a chart, and there will be a whole page of nothing but how do I set up the cool and adjust jumper for cooling airflow. So be sure and look at your installation information on the furnace that comes with the furnace to set up your cool and adjust jumper for cooling airflow. Right below your cooling bank of jumpers is a heating jumper. Now the heat jumper is to adjust your heating airflow. So if I have a W1 or a W2 call from the thermostat for first or second stage heating, it'll look at this jumper selection to tell it where it should be for heating airflow. Now, from the factory, we typically always set up our heating airflow from the factory on the furnace, because based on the size of the furnace, we already know what the heating airflow should be, so that normally doesn't need to be adjusted. But remember, based on the outdoor unit, the technician will have to set up his cooling and adjust the jumpers we just talked about. He will have to set that up. Now remember, team, please write this down or remember this. Cool and adjust will always be set up for 400 CFM per ton for full stage airflow on cooling. The heating airflow jumper will be factory set, typically for optimal operation. Now, one of the things I always encourage our technicians to do when they do their startup, Excuse me. Be sure and double check that heating airflow so that you don't overheat the furnace. Because you may have some undersized ductwork, or you may be running a pleated filter in the return grill or whatever, and so based on your airflow requirements, you may have to adjust that heating jumper as well. But always double check that during their startup and commissioning to make sure they have adequate airflow in the heating mode. Any questions or comments on the airflow jumpers before we talk about the rest of our jumpers? Okay, if you're going to use that humidistat that we talked about earlier for dehumidification with the dehume terminal, the humidistat yes, no is just a jumper. If you're going to use it, yes or no. If you're not going to use it, make sure it's in the no position. In addition, if you have this furnace on a heat pump, be sure and tell the board with the heat pump jumper yes or no. Yes, it's on a heat pump, or no. It comes from the factory, no, for straight cooling. But if it is on a heat pump, be sure and put that in the yes position so the furnace knows to look for that O terminal in the cooling mode on the O terminal. The fan speed, where it says fan speed, high, medium, low, that's for your continuous fan speed. Now, unlike our previous board that's going to give you a speed tap, so to speak, this is just strictly high, medium, and low. So if the homeowner goes to the thermostat sub-base assembly and goes from auto to on the fan, how fast will the fan run? Well, that's what this fan speed jumper is all about, high, medium, and low. Now, please write this down. Low is going to be about 35%. And the reason I say about, it's going to be based on your furnace model specific. But low speed will be approximately 35%, 35 to 40% of your cooling airflow. Medium will be 50% of your cooling airflow on your continuous fan speed. And high will be 100% cooling airflow. So on this fan speed is for continuous fan operation. In other words, you just have a G only call from the thermostat on the board for continuous fan operation, high, medium, low. Low is going to be about 35% airflow. Medium is going to be about 50% airflow. And high is going to be 100% cooling airflow. Any questions on that? Okay, well, down below, your fan speed selection is going to be your blower delay. That blower delay is your heating off delay. And again, that's field selectable from 60, 90, 120, or 180 seconds. Typically from the factory, we set that up on our furnaces for about 120 seconds. 90 to 120 seconds will be where the jumper is from the factory. And so that is field selectable for our heating off delay. That's our heating off delay. How long the fan will run after the call for heat goes away. You can have a field selectable jumper, 60, 90, 120, or 180 seconds. The last jumper we have on this variable speed ECM motor control board is what we call our staging jumper. Now remember, team, if you're stuck with a single stage thermostat, this allows you to give some staging between first and second stage heating on the control board. So if you're stuck with a single stage thermostat and you're only utilizing the W/W1 terminal, you can provide some staging on this furnace, but it's not auto. Unlike our previous board that had an auto function, this is strictly timeout. So on the variable speed 2-stage heat cool board that we're talking about now, it's strictly a timeout function of 10-minute, 15-minute, or 20-minute is the only selection you have. And so if you're stuck with a single stage thermostat, the contractor, if he wants to utilize this staging function, he'll be able to select 10, 15, or 20 minutes between first and second stage heating on the control board via the staging jumper. The final component on the board we're going to talk about is a model ID plug. This model ID plug, as you can see, is just a very, very simple wire jumper or jumpers on this plug. It's nothing complicated. It's not a bunch of resistors or any sort of like a memory EEPROM or anything like that, or a memory stick or nothing. It's just strictly a simple jumpered wires jumpered on that plug. And what that is, it's a model ID plug. So what that model ID plug does is it tells the board what size furnace it's hooked up to. And so it's important that if you have a replacement board you take the model ID plug off the old board and you snap it onto the new board. And as soon as you power it up, as soon as you power up the new replacement board, it'll automatically know what size furnace it's hooked up to because of that model ID plug. So this is very, very important. We stress this if we sell a replacement two-stage variable speed board like what we're looking at. We want to make sure and remind the technician to take the model ID plug off the old board and snap it onto the new board, because that way then the new board will know what size furnace it's hooked up to. So that model ID plug configures the board for the size of the furnace it's hooked up to. And so this is really good news for all of our wind locations that are selling this product, because now instead of having 47 different boards that you have to keep in stock, this two-stage variable speed board is one SKU or one part number, and then based on that model ID plug that you snap on will tell the board what size furnace it's hooked up to. Any questions or comments on this board before we continue? Well, team, I'll tell you what, let's go ahead and open the floor up. Unmute your mics if you have any final questions or comments on our ECM product overview. Let's go ahead and take a minute or two to answer those questions for you. What we've done is we've gone over some control boards. We've gone over some low voltage wiring on our ECM product. And so please, at this time, if you have any questions or comments, please open up your mic and let's take those questions or comments at this time. And so go ahead and do that. Open up your mics and let's have some final questions or comments if you have any. Is everybody good? Okay, team. Well, if there are no final questions or comments, let's go ahead and conclude for the day. And we want to thank you very much for your attendance. Thank you for training with us today. And by all means, please keep us in mind and coordinate with Jill, Polly, if you have any further training needs. We'll be more than happy to set up some training sessions with you again in the future. And one more time, thank you again so much for your attendance, and we'll talk to you later. Please have a great day. Thank you.
Thank you, Joel.
You bet. Thank you.